Ay, kaya pala, sorry, I was on mute mode. No? So, okay, once again, let me repeat, guys, from the beginning. Okay, so today we're going to we're going to have another example of a decision tree using the rpart package. So kindly make sure that you have your rpart and rpart.plot package installed and required and accessed. I was asking questions a while ago, but we were on mute mode, so I'm sorry about that. So have you met the data, the iris data set before? Guys, pakichat na lang please. Have you encountered this? Have you used this before, yung iris na data set? Okay, not yet. Thank you. Okay, so the data iris, the data set iris comes with R, so it's already preloaded in R. So let's access that. So let's use the function data iris. Okay, so I'm having a problem with my environment. Okay, so I can't see. Kanina pa to eh. I can't. I don't know how to. I've been trying to manipulate this and trying to see. Okay, so it does not appear, no, yung mga objects na linode ko. Anyway, so let's take a look at the structure of the iris dataset. So the iris dataset, it's a data frame. Okay, it consists of 150 observations with 5 variables. So ang variables niya, sepal.length, sepal.width, petal.length, and petal.width, and species. Okay, so the 4 are numerical variables. And the last one, the species, is a factor. So you have 3 types: setosa, versicolor, and virginica. Okay, let's view it. Iris. So what can we find here in the iris dataset? Okay. So these are the variables here: sepal length, sepal width, petal length, petal width, and then setosa. This is treated as a factor variable, and we would like to make a decision rule. Okay, when will we decide if a particular leaf is a setosa, or if it's versicolor, or versicolor, or the last one is virginica. Okay, so that's the decision rule that we want to make, and we want to develop a decision tree out of this, so that from that decision tree, we can determine if a particular observation belongs to setosa, to virginica, or versicolor. And then we'd like to see how good our model is by computing for the percentage of correct prediction, and then percentage of incorrect prediction. Now, as we know, guys, when we do machine learning, this is part of supervised learning. Okay, the variables are defined, and we know what we want. We know that we want to predict the type of I think this is species. Sorry, species. So let's just run this. Had the first 6 elements. Okay, sepal length, sepal width. Okay, and then we're going to, as I mentioned a while ago, we're going to make use of decision tree in order to determine, based on these parameters, if a particular flower is belong to setosa, or versicolor, or virginica. Okay, so first we're going to, as you know already, we're going to split our data, partition our data into 2, training and testing. So we can make use of the sample function. Okay, so we're creating an object called index. Okay, we're going to split our sample into 2. We can make it 3 or 4. It depends on our requirements. So just two partitions. And the number of rows is the number of rows of iris. Okay. So what it's saying here is that we're going to create 2 partitions, and each of them has 400 rows. Why 400? Because the iris data set has, 150, 150 observations. Okay. Each of these 2 partition has 150 rows. Okay. And then replace is equal to true means that when we get a data, it's like getting a data from a bowl. It's like getting a marble, for example. And then when you get that data, you record that, and then you can put it back. So that that means that you can pick that data again. And the division that we're going to use is 70%, 30%. Okay, so let's do this. Let's run this. Okay, in order for us to have the same random distribution of our data, training and testing, we will set that seed. I'm using 9850, can be any arbitrary number. Okay, so this is now the view of our ind object. Okay, 22111, what does this mean? Okay, so the classification here, 2 means, okay, so first observation and second observation will go to sample number 2, while 3, 4, 5 will go to sample number 1, etc. Those that are marked 2 will go to sample number 2, and those that are marked 1 will go to sample number 1. Okay. So once we have the index, guys, we can now partition our data. We will call training those that are indexed as 1, and then we will call testing data those that are indexed as 2. So they're coming from the iris data set, and then here its index is equal to 1, comma. That means all that were classified as 1, and then all the columns are included, comma, blank, which means all columns are included. This one also, testing data from the iris data set, and then we're going to subset. The bracket there stands for subsetting those that belong to index number 2, and all the columns are included. Okay, so let's run this. Okay, so we have now here 2, training and testing. Okay, so for the training data, we have 104 entries. So this represents the around 70%, because we included in our code, in the sample code, that the division should be 70-30. And 70% of 150, that's around 105. Okay, so practically this is 70%. And the testing will of course have 46 observations. Okay, that's 30. That accounts for 30% of our data set iris. Okay, are we clear so far, guys? Paki-chat nga please kung clear so far yung first 35 lines natin. Okay, thank you. Si David lang may sumasagot. Pierre, thank you. Yung iba. Okay, sorry, konti lang kayo. No? Hesed, John, so far, clear ba tayo? Okay, thank you. Okay, thank you, John. Thank you, Hesed. Thank you, Pierre. Okay, thank you, David. Okay. All right. So let's now model our data. No? Magmo-model na tayo. Remember that we used before rpart. rpart. Okay, so let's create a tree. Let's call it T1. Okay. And T1, you use the rpart package, the function rpart. And then this is our dependent variable species. And the tilde there refers to, guys, diba, where this in linear modeling, this is regressed, no? And that means that we use all the variables. There are 4 independent variables that we're using here. Okay, ano yung mga independent variables na yan? Okay, ito yung sepal length, sepal width, petal length, petal width. We would like to use these variables in order to determine if this type of flower is setosa or versicolor or virginica. So that's what we're trying to do here. Okay, so let's run this tree, and then let's print T1, okay. And and you see that there are, of course, there will be 3 terminal nodes kasi tatlo yung ano natin, no? Tatlo yung, we have 3 factors. So what does this tell us? Okay, what does this tell us? So all in all, guys, the root, okay, 104, 68. What does this mean? And what do this mean, guys? These 3 probabilities. So there are 104 observations because we use the training data set. Okay, so what does this mean, guys? Do you understand what this means? So for example, itong number 2 na to, what does this mean? Petal length less than 2.65. What does the 35 and the 0 here mean? Can anyone guess? Okay, so it's quite difficult to decipher, no, this part of the output, the 3. Okay, pero yung ano dito, guys, itong mga asterisks dito, this means these are your terminal nodes, no? So this asterisk here means it's a terminal node for your setosa. This asterisk here means that this is the terminal node for your versicolor, and lastly for your virginica. So it's best to look at this in a diagram form. Okay, so we're going to use the rpart package. We already used this before. So dito, okay, hindi ko nalagay dito yung yung iba. Okay, anyway, so let's just run that question mark there. We'll get insights on how to use that rpart. Okay, oops, no. Okay, ito. This one. So when we run this, that question mark r.plot, it gives us some information about this rpart.plot. So that's the from the package rpart.plot. So it's used to plot in an rpart model. Remember, our tree, guys, was derived using the rpart package. Okay, so you can look at this. So this is the default. Okay, r.part plot, and then you have the type. Okay, and then we have some other. You have also fallen.leaves, which are used here. Okay, and we can look at the explanation. For the type, you have 0 to 4, and then 5, and then there's actually 100 there. Okay, sorry. Ang type lang 0 to 5 lang. Tapos yung extra pala yung ito yung list ng extra 0 to 11 tapos plus may 100 pa. So you can look at this, okay, and try to learn what are the functionalities that are available in this plot. Okay, but suffice it to say, guys, for us that yung sa extra, okay. So ito may mga instruction, for example, extra is equal to 106, class model with the binary response, plus extra is equal to 104, having more than 2 levels, etc. So dito, for our purposes, okay, number 1, so 0 is no information, extra is equal to 1 displays display the number of observations that fall in the node per class, okay, and then prefixed by the number of events, okay, similar to text.rpart, okay. So we'll use this, and then plus dito pa, sabi plus 100, okay, to any of the above will also display the percentage. Okay, so gusto natin hindi lang yung number of observations that will fall under that category, but also the percentage. So i-plot muna natin tong una, okay? Our part. Okay. So this is our decision tree. No? This is our tree diagram. Okay, so it's very easy to to explain this. Okay, so dito, what does this tell us? So una yung color code natin, ito, yung parang orange, it's for setosa, versicolor, it's for the gray one, it's for versicolor, and the green is for virginica. So what does this tell us? What's our decision here? Okay, so ang sabi dito, take a look at petal dot length. No? If petal dot length is less than 2.6, okay, definitely setosa na kagad dyan. Okay, and that the probability that it will be setosa is 100%. So sure na sure daw. 100% sure na if the petal length is less than 2.6, then it's setosa. And 34% of our sample belongs to this one. Okay, the next, pag hindi, if the petal length is not less than 2.6, then we go here. No? We look at the petal width and ask, is the petal width less than 1.7? So if it's less than 1.7, then it will be versicolor. And the probability of that being versicolor is 95%. 0 yung probability na setosa siya, 5% yung probability na virginica siya. Okay? And 37% of our sample belongs here. And then lastly, if it's not less than 1.7, if the petal width is not less than 1.7, then it will be virginica. And that's where the probability that it will be virginica is 100%. Okay, so that's what the model is telling us. That's how the model is predicting our dependent variable species. Okay, let's try to see, guys. Let's see if our model is doing good. Okay, Pierre, yung percentage dun sa terminal nodes that refer to dun sa ano natin sa forecast natin, dun sa prediction, 34% were predicted setosa, 37% predicted as versicolor, and 30% predicted as virginica. Okay, so let's evaluate, guys, kung okay nga yung ano. Ito pa pala, no? Ito guys, you can add type is equal to 4 and extra, may extra type dito, 101. Okay, extra 101 is equal to 1 plus 100. Sabi ng model, pag nagdadagdag ng 100 dito, idadagdag niya yung percentage of observations in the node. Okay, fallen dot leaves, what's fallen dot leaves? Okay, fallen dot leaves, this is more appropriate if you have a big model. Default is equal to true. Okay, default true to position the leaves at the bottom of the graph. Kasi pwedeng i-position natin yung leaves na pakanan, okay, at saka pakaliwa. So there's a functionality for that. Asan na yan? Okay, I can't see here. Incomplete kasi dito yung yung functions. Ano lang to? These are just samples of the functions that you can see from our part that plot. There are other functions as well. Okay. So may question ba? Okay, thank you, Pierre. Let's run this code, this line. Control Enter. Okay. So dito, I think pareho lang ng previous, ano? Okay, so it's the same as the previous. Okay, not so much difference between this one. Although mas ano to, ano, mas dito kasi pinakita yung ano yung itong parameter na to, petal dot width less than 1.7, dito greater than 1.7. While in the first one, ito yung basic lang. Okay? Basic lang siya. Okay, so mas magandang plot yung pangalawa, mas informative siya. And of course, you can still modify this and include other parameters. Okay, and you can research, you can read yung documentation ng rpart that plot. Okay. Okay, any questions, guys? All right. So, thank you. Okay, so let's move on, guys. Itong ano natin, let's predict now. So here we're creating an object called P1. So this is prediction for our training data set. So function natin predict using the model T1, okay? And then predict the training data set. So let's run this. Okay, so what will it generate? Okay. I'm sorry, hindi nag-generate yung ano ko, I don't know why, kanina ko pa dinidecipher to eh. Why my environment does not register the codes. I've been trying to look for the reason why. I've tried to turn it off and on, pero hindi pa rin. So never mind, guys. So let's try to view ano ba yung P1? View P1. Let's see. Okay, so this is P1, no? Notice that P1, yung ano niya, yung prediction, okay, how many observations do we have? 104, no? 104, bakit 104? Kasi pinipredict natin dito yung training, di ba? Eh yung training, there are 104 observations. So we expect dapat yung prediction 104 din. So ito, guys, this is observation number 3, no? From the iris data set. Kasi remember, guys, yung training natin, ito siya, 3, 4, 5, 7, 8, 9. Ibig sabihin, si observation 1, observation 2, andun siya kay testing data set. Tingnan natin si testing. Yan, no? Number 1, number 2, 6, 11. So those that are not part of our training data set are with testing. No? Okay? So we predicted training. No? Let's see. Ang prediction sa sample number 3 is setosa, no? Setosa 1. 0 yung versicolor, 0 yung virginica. Let's see. Okay, so correct yung observation. Correct yung prediction. Kasi ang actual, setosa. Okay, so let's try to see. Kasi ang okay, so I forgot to do something here. No? Okay, nako. May nakalimutan ako. Pero okay lang, sige. We just continue. So random din naman yung sample. So we can find here that sa model natin, yung first 1, 2, 3, ilang to? First 12 was predicted to be setosa. Okay? So dito naman yung first, first 12 setosa. Mukhang tama, no? Tama yung prediction based on our model. Okay, so however, guys, yung prediction natin naka probability siya, no? Ito. Okay, nakaganto siya. So later on, pag i-compare natin to sa training data, dito sa Setosa, etc., hindi natin actually pwedeng i-compare si P1 kay training natin. Kasi kay training natin, ang kukunin lang natin yung species. Okay? Pero kay P1, meron tayong tatlong rows, tatlong columns. No? So what we need to do is to specify natin yung P1 natin should not be this one. Okay? But what we want is the P1 that is just determining the class. No? Kaya nga dito tayo may type class. So enter natin to. Okay, so we now have P1. Okay, and then let's view P1. Okay, so ano na yung difference ngayon? Yung P1 natin kanina na we did not specify type is equal to class, it gave us an object, a data frame with 3 columns. Okay? Dito guys, ang ano natin, when we define type is equal to class, it gave us just 1 column, no? So ito na yung P1 natin, Setosa, ito. So pwede na natin i-compare yan dun sa training dito mismo sa species. Okay, so let's do that. Okay, ano ba yung class ni P1? So P1 is a factor. Okay, here we're going to create, lagyan na natin to separately. Okay, we're going to create a table where we are going to call it tab 1, table siya. Tapos, we're going to give it a name predicted is equal to P1. Ano yung P1, guys? Ano yung P1? Diba? Ito yun, no? Ito yung one line na yung class lang. Okay? Now, a common mistake here is, balikan natin to, balikan natin to. Sandali. Sige, mamaya na, no? So, predicted natin P1, and then yung actual natin, this will be on the x-axis, yung sa taas. It will be coming from training $species. So, only the species column of the training data set. So, let's see if we can create a table out of this. There. So, print tab natin. Okay, ito yung table natin. Okay, that's our table, our tab 1 table. Okay, so ang daming tamang ano niya, no? Now the reason why halos perfect yung ano niya, ang ganda ng ano niya prediction is we forgot guys to itong iris natin. Asan yung iris natin? Itong iris data set natin. Naka-arrange kasi siya ng ano yung Setosa first and then versicolor and then virginica. What we forgot guys is to rumble this. No? Hindi natin na ano siya na rearrange. So I leave that to you guys to discover paano kaya mas magandang gawin natin dito sa modeling natin. Mas maganda muna na randomize muna natin yung order nitong ano species natin. Kasi magkakasunod yung Setosa, magkakasunod yung versicolor, magkakasunod yung virginica. Would the result still be the same if we had rearranged the order of species? Okay, so I'll let you explore that kung anong gagawin pag ganyan. Tapos maybe we'll just compare kung ano nangyari kung randomize natin yung ordering nito para ano siya yung hindi siya parang arranged na data. Okay. All right. Okay, so where are we now? Let's go back here. Now, what if, okay, let's go back here to P1. No? Kung ito yung P1 natin, guys, control enter. So, okay, na-notice you guys, si P1 natin na bago na. Ito na naman yung kanina, no? P1. So, it's three columns, okay, by 104 rows by 3 columns. Now, if we ask R to create a table using the P1, yung P1 guys na ito yung tatlong columns, what will happen? Okay, sabi natin create a table, no? Using P1, yung nauna that will be on the y-axis. Okay, yung pangalawa, that will be on the x-axis. Let's try to run this. Tingnan natin. Okay, ano nangyari guys? Nag-error siya, no? Error in table. Okay, all arguments must have the same length. Okay, now, nag-error siya kasi guys, yung P1 natin ngayon, ito na, no? Our P1 is 104 rows nga, okay? Pero 3 columns. While yung training natin, yung pinapaano natin na table, ito, no? Training data, okay, which is this one, and then only the species. So that's 104 rows, pero ito lang yon, 1 column. So ingat lang guys pag naghahanap ng nagpe-predict kasi baka sa work nyo baka magulo kayo dito, no? Make sure that yung predicted value nyo guys, okay, this one, make sure na isang ano lang siya, isang column. If you're going to compare it with the actual value. Okay, so let's bring this back. Okay, para tama yung P1 natin. Okay, so if you run this, okay na to. I run everything na lang. Okay, so what does this mean? This is your confusion matrix. Okay, confusion matrix na to. So ang sabi nito na yung predicted value natin, sabi natin, di ba kanina ito? Predicted is equal to P1. So nasa y-axis siya. Actual, yung pangalawa, nasa x-axis siya. Okay. So here, yung predict natin na yung isang data is setosa 35. And it turned out na setosa sila. Tama lahat. So dito, sabi natin, yung, yung diagonals natin are the ones that are correct. Iisa lang yung hindi correct. No? It was predicted to be versicolor when in fact it was virginica. Okay, itong 2 na to. So I have, may suspicion tayo dito kasi yung data natin, yung arrangement eh. So as I said a while ago guys, it will be good for you to try to see paano kung nagbago yan, kung randomize natin yung arrangement ng data. Okay, so try that first and then try to see what will happen. Will the percentage of correct predictions, okay, be very high, as high as this, okay, or not. Okay, then let's now use our model, itong T1 natin. Ang gawin natin sa T1, i-run natin doon yung testing data natin. Okay? So I'm creating an object called P2 and then I'm going to predict using the T1 model. Okay, sino si T1 model natin? Ito kanina, yung rpart natin. This one, where we regressed species on the training data. No? However, we will now make use of the testing data and let's see if this model can also predict well if it's going to make use of a data that it has not yet seen. Hindi pa niya nakikita. Ito sa testing data kasi hindi pa niya nakita to eh. Hindi pa nakita ng model na to. So let's try to see. Okay, so once again, we predict isang ano naman siya, 46 rows. No? 46 rows kasi ito na yung training. So ganun guys sa machine learning, what we do is to split the data. And the reason why we split the data is that we don't want the model to overfit. Ano ibig sabihin ng overfit? Kasi ginagamit na lahat ng data natin. So there's a chance guys that yung overfitting, yung masyado niyang inano yung data, no? For the lack of a better Tagalog term. So what's being done usually is that we split the data into a training data and a testing data. Tapos we run the model using the training data and then we see if it will work in the testing data. Okay, so that's what we're doing here. All right, so let's now come up with our confusion matrix. No? Confusion matrix, run natin to. Okay. All right, so here, okay, setosa guys, setosa 15. Okay, 15 ang correctly predicted. Okay, 12 yung correctly predicted kay versicolor and 15 yung correctly predicted kay virginica. Kay Virginica may dalawang incorrectly predicted. It was predicted to be Virginica when in fact it was versicolor. Kay versicolor naman, dalawa din yung wrongly predicted. Kasi si versicolor, predict niya na versicolor siya, pero dapat Virginica pala siya. So here you have four that were misforecasted or mispredicted. 91% yung correct prediction, and then 8.7% yung wrong prediction. Okay, so this is just a very quick example of our decision tree using the IRIS dataset, which is just to reinforce what we learned last time. Kasi last time, guys, matagal-tagal na yon, no? So I just wanted us to recall yung rpart. At saka also, that's also your project number 1, yung decision tree. Okay, any questions so far, guys? That takes care of the other example for decision tree. Notice, guys, yung decision tree natin, yung dati, yung heart data natin, yung cardio data. Notice that our decision variable, dependent variable, sorry, not decision variable, our dependent variable is categorical. No? Dito din categorical. You can also use decision trees for quantitative or continuous variables. Kaso medyo mas mahirap siya, medyo mas iba yung ano. So I leave that to you as a potential subject of your project, no? Na ang gagamitin nyo is a continuous or quantitative variable for your dependent variable. Pwede rin yun. Okay, any questions? Okay, so no questions. Let's now go to I want to first discuss, guys, yung logistic regression kasi ita-tie up natin yun sa fast FFT, sa fast and frugal trees, no? And also, guys, you can compare yung logistic regression, yung output niya with our decision tree. You can use rpart for it. Okay, so kindly open that, guys, yung logistic regression. Okay, I also posted that dito sa ano natin. This one. Okay. Logistic, and then kindly we'll download nyo rin syempre itong binary. Ito yung gagamitin natin na data for logistic regression. Okay. Who among you have done logistic regression before? Hindi ko maalala kung nag-logistic yung mga students ko sa arts kung nakapag-logistic regression tayo. But let me ask, guys, who among you did logistic regression before? Or you know how to do binary logistic? Kasi dalawang klaseng logistic regression. You have binary logistic regression and you have the multinomial logistic regression. Pag binary logistic, as the name suggests, dalawa lang yung DV natin, yung factors, yung levels. Pag multinomial, okay, you have more than 2. Okay, so may I know, guys? Okay. Okay, thank you, Pierre. Thank you, John. Yung iba, si Hesed. Okay. Si David, ano ba? Kamusta? Na-meet yun na ba si logistic regression? Okay. All right, thank you. This is also a good opportunity for us to learn yung logistic regression natin. Let me just open that. Okay. All right, so this is logistic regression. Okay, X muna natin. Okay, binary logistic regression, guys, ibig sabihin, yung dependent variable natin, dalawang factors, no? So when do you use logistic regression? We use logistic regression, whether it's binary or or multinomial, if our dependent variable is a factor. It's a factor. So ibig sabihin, it can be classified as true or false, 0 or 1, binary siya, dalawa. Pag multinomial, several levels. Okay, so let's, do you have the file open already, guys? Okay, open na ba? Okay, so load natin guys si binary data natin. So let me just use this import dataset para mas mabilis. Import from text, and then saan na ba yun? So it's in my desktop. Okay, and then FINANLY decision tree. So nasa, wala dito. Nasa ibang folder. Okay. Wala. Where did I put that? Dito. Yan, logistic. Okay, there. Binary. Okay, and heading, okay. May heading tayo. Okay, then we can just name this. Kung gusto, i-name na lang natin na my data. No? My data. Para pareho dito sa code natin dito. Okay, import. Okay, so yun siya. No? So let me go back to our code. Copy ko na lang to. Okay. Kinapi ko yung code dito para next time when I open this, diretso na, no? Just click it. Okay, so let's take a look at our data first. Always, guys, understand your data. No? So here we have 4 variables: admit, GRE, GPA, and rank. So what are these variables all about? These are applications made to, I think, an MBA school, no? Okay, MBA school yung nito, yung data na to. Tapos yung admit, this is what happened when the applicant applied for that MBA degree program. No? So ibig sabihin sa respondent number 1, hindi siya na-admit dun sa university nito. Okay? And this applicant number 1 had a GRE. Yung GRE, guys, parang ano yan, parang NMAT or parang exam din yan, ano? I just forget the meaning of GRE. Check nga natin para kalimutan ko yung meaning ng GRE. Okay, so para sure lang tayo. GRE. Okay, graduate record examination. So it's a standardized test. Okay, so yan ginagamit yan pag mag-a-apply ka ng masters, no? GRE. Okay, so let's just make sure that we understand this. Yan. Graduate record examination. Standardized test siya, requested by universities in the US that students take prior to enrolling to a master's degree. Okay? So it's most popular sa business schools, and MBA. Very popular yan sa MBA. Okay, so meron tayong GRE. And then meron tayong grade point average, yung average ng student dun sa college niya. And then rank. Yung rank, guys, renate nila yung mga schools where the student came from. 1, 2, 3, 4 yan. 1 to 4. 1 being the best rank. No? 1 rank, 1 ibig sabihin, maybe Ivy League yung school, maganda yung school na pinanggalingan ng student. 2, okay din pero not as good as the first one. And 3, medyo ano na, and of course 4, yung medyo sabihin natin na based on the assessment, ito na yung medyo pangit na school. Okay, so we have this data. Now, we would like to determine, based on GRE, GPA, and rank, we would like to determine and create a model of admission. Okay, so that for example, next time a student applies, tapos may GRE siya, may GPA, at saka rank ng school, alam natin, we can predict whether that student will be accepted, admitted, or not admitted. Yun ang ginagawa nito. Now, since our dependent variable, admit, will have two levels, so 0, not accepted, 1, accepted, then that's why it's called binary logistic regression. Ngayon, kung maraming parameters, kunyari 3. Kunyari, you're looking into the characteristics of a student, kung ano ba siya, kung magiging summa cum laude ba siya, o magiging magna cum laude ba siya, or just a cum laude. Example lang yan, guys, no? Or regular lang, 4, walang honor. So 4 'yun, di ba? 4. So ano din siya? Kasi yung dependent variable natin, kung magiging summa siya, kung magiging manya, kung magiging cum laude or no honors. So since there are four levels there, ang gagamitin doon ng model, guys, is multinomial logistic regression. Okay? So for our purposes, guys, halos pareho lang naman siya ng principle. Mas medyo may konting complication nga lang sa multinomial, pero the same principle as a binary logistic regression. So let's go back here. So 400 observations, 400 yung data na ginagamit natin. Okay? Okay. All right. So first, let's take a look at the structure of our data. Structure ng data natin. Okay. As I mentioned a while ago, this is a data frame. And then you have the admit variable as it's an integer. Okay. GRE integer, GPA numeric, and rank integer. Okay, yung admit, guys, ayaw natin na ayaw natin na integer yan kasi hindi naman number yan. So we will be converting it as a factor. Ganun din yung rank, no? The rank 1, 2, 3, 4, we will be converting it as a factor. Ibig sabihin, gagamitin siya na classifier. Okay? So the code to convert, no, yung admit variable natin, so ito my data $admit, ibig sabihin we're creating this object, or same object pa rin, tapos kino-convert lang natin si my data admit as a factor. Also with rank, no, gusto natin si rank not numeric, not an integer, but rather rank as a factor. So let's run this. Okay, let's check if my data has already been converted. Okay, there. So take note, si admit ngayon, guys, factor na siya. Okay, and rank also is now a factor. Okay, so hindi na sila integers, so we can proceed now. Okay, since lalo na, guys, kailangan natin talaga ma-convert yung ano natin, yung data natin sa R as factor kasi gagamitin natin si admit as a dependent variable, no? All right, we can create the two-way table. Ang ano yan, X tabs yan. Okay, ano yung gagamitin natin? Si admit nasa y-axis, si rank nasa x-axis. Okay, ang data natin, my data. This will now classify ilan yung na-admit na under rank 1, rank 2, rank 3, rank 4, tsaka ilan yung mga hindi na-admit. No? Okay, let's run that. So see, nasa y-axis natin si admit, si rank nasa x-axis. No? So of those that applied for NBA, okay, 28 were not admitted from rank 1 schools. No? 97 were not admitted from rank 2, 55 were not admitted from rank 4 schools. Okay, those that were admitted, okay, 33 came from rank 1 schools, 54 came from rank 2, 28 came from rank 3, and 12 came from rank 4. So ito yung ano natin, guys, yung table, no? Yung table natin ng we call it the contingency table, di ba? Ito yung table ng classify natin how many were admitted coming from the different ranks and how many were not admitted coming from the different ranks. Okay, clear so far, guys? Clear so far? Okay. Thank you, David. Thank you. The rest, guys? Okay lang ba tayo so far? Pasensya na kayo, guys. Kayo lang yung students ko ngayon, kaya kayo lang nakikita ko, no? Okay, thank you. Thank you. All right, now, before we do anything else, guys, bago tayo mag-regression, ano natin ulit, we're going to partition the data. Guys, I'll just get water sandali. Okay, thank you. All right, so partition natin, you know this, guys, we have done this several times. Set that seed tayo para pare-pareho tayo. 80% ilalagay natin sa training, 20% ilalagay natin sa testing. Okay, so usually nagbabari yung ano niyan, yung percentage, but most oftentimes I see 70% to 80% yung training and 30%, 20% to 30% yung testing. Although minsan pag malaki yung data set, may nakikita akong 50-50 yung ginagawa nila na partitioning. Okay, so it depends on the size of your data. Okay, set that seed natin 1, 2, 3, 4. And then again, ito yung ginagawa natin kadalasan or several times na we're going to create an object called index. And it's we're going to sample, dalawang samples ang gagawin natin. Okay, and it should involve yung rows natin, yung rows ng my data. Okay? So dapat 400, kasi 400 yung rows ng my data, dapat 400 rows din yung dalawang sample na yun. They should have the same rows. Sorry. We're using the 400 rows of my data. And then syempre magkakaiba pa lang rows sila, no? Kasi yung isa 80% nun at saka yung isa 20%. Okay, yung probability natin ng distribution 80 and 20. Okay, so the train data are those with the index 1, test data are those with index 2. Let's run this code chunk together. Okay, so yan, no? Okay, and then we can see the train data. Asan yung train data ko? Okay. Dali, magtanggal muna ako, guys, ng ano ng control. Ang dami na kasing ano control W. Ito mahirap, no? Asan yung train data natin? Training ba? Wait. Control W to delete the tab. Okay, saan na? Diba nag-train data na tayo? Ay, hindi ko pa na-view. Okay, so let me view, guys, yung ano. Hindi nag-appear dito sa ano ko sa environment View, train. Okay, let me run that. And then view, test. Okay, so train. Okay, train has 325 observations. 80% kasi ng ano, 80% ng 400, that's around 320, so more or less, no? Hindi niya ine-exact, no? 325 for train data, and si testing naman, 75 entries. Okay, so if you take a look at our train data, siya yung observation 1, 2, 3, 4, so wala si 5, di ba? 5 kasi napunta siya dun sa kabila kay test. Si test naman, ito yung 5, 14, 16, ito yung mga observations na to. Okay? Okay, so let's continue. We have now created our train data and testing data. Okay, so we will now do logistic regression model. Okay, show of hands lang, guys, who were sino sa inyo were my students before in arts? Hindi ko maalala kung may estudyante ko kayo sa arts. Anybody who was my student in arts? Paki-chat nga kung no. I see. O nga pala sa si Hesed sa FinStud. Okay, sa peer sa FinStud. So may kahit pa paano may idea kayo ng R, no? Pero sino to? Mr. Cortero sa arts. John, were you my student in okay, FinStud din. Okay, so may mga kahit pa paano may working knowledge kayo ng R. Okay. So sa R guys, 'di ba, pag nagre-regression tayo, LM, no? Pag logistic o multinomial pag binary logistic regression or multinomial logistic regression, we make use of the GLM, generalized linear model. Okay? So let's now create a model. Let's call it my model. Okay, and then we're going to use the GLM. Okay, GLM guys, yan ang gagamitin kapag logistic, no? And then our dependent variable is admit, and then regressed against GRE, GPA, and rank. Yung tatlong yung tatlong independent variables. Or you can just use tilde and then that, no? And then data is equal to train, and then we have to include this. Family is equal to binomial. We have to show that, guys. Ang family natin binomial kasi iba't ibang families eh. Okay? All right. So, tingnan natin guys, ha? I-ano natin dito, GLM. Okay, just for us to have an idea. Okay, GLM, generalized linear model. Okay, let's wait for that function. Yan. Okay. So we have it now. It's from the stats package. Yan. Okay, so we have here GLM, yung formula natin, kung anong family siya galing, yung data na ginagamit, and there are several other parameters there that we can use. Okay, so dito sa in the family, guys, for a description of the error distribution and the link. This can be a character string, okay? Okay, so ano na yung mga pwedeng family? Let's take a look at this. Okay, so pwedeng binomial, pwedeng Gaussian, okay, pwedeng gamma, inverse Poisson, quasi-binomial, quasi-Poisson. So maraming pwede, no? Maraming pwedeng families ng dito sa generalized linear model. So for us, we're going to use the binomial. Okay. So run natin to, guys. Run. Okay, let's run this. And then here you have our output. Okay. Call. Ito na yung ginamit natin. Generalized linear model. Ito yung function natin. Okay. So we have the ito yung mga residuals natin. Okay. Summary stat nila. Minimum, maximum, etc. Okay. We're now interested in the model. Okay. So ito yung coefficients natin. Ano? May I ask guys if dun sa FinStud natin nag-regression tayo? At least introduction ba tayo to regression dun, guys? Paki-chat lang. Okay, yes, good. Ibig sabihin, medyo familiar kayo guys sa pag-interpret nito. Okay, let's take a look at this. GRE is not significant. So mukhang hindi natin dapat isasama sa model to. Sa rank, guys, rank 2, 3, 4. But since rank, guys, these are dummy variables. So kahit na hindi significant si rank 2, pero si rank 3 and 4 significant, dapat kasama pa rin to si rank. Hindi natin kasi pwedeng itanggalin lang si rank 2. Kasi dummy variable si rank 2 born out of the rank variable. Okay, take note, rank 1 is not included here. Bakit, guys? Would you know why there's no rank 1 here? What do you recall? If you can recall, or hindi ko alam kung na-discuss natin yan. Kasi hindi pa naman talaga regression yung discussion natin dapat sa FinStud. Extra lang yun. No? Anyone, guys? Bakit rank 1? Wala. Okay, kasi guys, itong rank 1, iba categorical variable siya. Ilan yung levels niya? Ilan yung levels? 4 levels. 1, 2, 3, 4. Okay? Now, pag ganun, we will be replacing these categorical variables with k-1 dummy variables. What do I mean by k-1? K yung levels. Since there are 4 levels, yung rank 1, rank 2, rank 3, rank 4, ang i-introduce lang natin na dummy variables will be 4 minus 1. So tatlo lang. The other one will become the benchmark variable. Okay, so dito nakita natin walang rank 1. Otherwise, guys, pag in-introduce din natin sa rank 1 as a dummy variable, as a variable then magkakaroon tayo ng problem sa hindi magra-run yung model natin. Depende sa software, but we will fall into what we call the dummy variable trap. So if you have a regressor, an independent variable that you're treating, that's a factor, sa output nyo, there will only be n factors minus 1 dummy variables. Yun lang yung lalabas doon. No? Okay? So how do you interpret this? Interpret this compared to the benchmark variable, which is rank 1. For example, ano ibig sabihin nito? Negative 1.12. Okay, ibig sabihin nito, si rank 1 daw, okay, has negative 1.12, has negative 1.12 lesser log odds ratio compared to rank 1. So you're always comparing it to rank 1. I'll explain this in greater detail after this. So here we can see that GRE is not significant, no? So hindi pa final model to, tatanggalin natin si GRE. So in the next one, in the next model, okay, we created this model, my model, and GLM ulit. Then same thing, pero natanggal na dito guys yung nawala na si GRE. No more GRE. Admit, and then we remove GRE because GRE is not significant in determining, in predicting kung maa-admit ba o hindi yung student. And then sabi natin si rank, kailangan pa rin yan. Okay? So the same thing, guys. Let's see if our model changes. Okay, there. So now, GPA, in fact, it's more significant kasi naging 3-star siya. Rank 3, rank 4 is still significant. So this will be our final model. Sabi natin, hindi natin pwedeng tanggalin si rank. Kasi rank 3 and rank 4 are all significant. Okay, let's now quickly, I have to discuss this, guys, kasi I would want you to compare this with a decision tree model. Okay, so at least alam nyo yung logistic regression. Okay, and then later on, i-predict natin, guys, kung ilan yung how powerful, how good our model is in predicting kung ma-admit yung student o hindi. Okay, so let's take a look at this. So, ang equation natin, guys, will be, dito siya, sinulat ko na dito. Okay, sige, mag-predict muna tayo, no? So here, we're going to predict first. Okay, so again, we're creating an object, P1. Si P1 is a prediction of my model, okay? My model using the trained data set. No? The trained data set and type is equal to response. So kanina, di ba, class? So tingnan natin kung ano mangyayari dito. Okay, and then head P1. Okay. So ito ngayon, guys, yung prediction niya, no? So predict natin si trained data, okay, consisting of 325 observations. Okay? Ang lumalabas dito, guys, are the probabilities. So ano ibig sabihin nito? What does this mean? 1, guys, 1. Si observation number 1, kay trained data, the probability that it will be accepted, admitted, is equal to 28% lang. Okay, see observation number 2, the probability that it will be accepted is almost 30%. See number 3, 68%, etc. So the values that are being predicted are probabilities. No? Kasi nga, di ba, ang ano natin, ang dependent variable, ano siya, yung binary, ma-admit ba o hindi? Okay, so ang binibigay sa atin na result ng model are probabilities, whether the applicant will be accepted or not. So kapag 0.5 and above, ano yun? Accepted. Okay? Kapag below 0.5, then reject yun. Okay. So that's, ilan natin to pareho, no? Yung head ng P1 natin. P1 is the prediction. And head ng train. Okay. All right. Let's take a look at this, guys. Okay. So, si unang ano natin, number 1 observation. Okay. Na-admit ba siya? Na-admit ba siya number 1? No, di ba? Na-reject to. Ang prediction natin dito, 0.28, 28%. So, ibig sabihin 28% less than 0.5. So, not admitted to. So, tama ito. Tama yung prediction natin dito. This is the actual 0, hindi siya na-admit. This is the prediction. Okay, second, guys. Predict natin 30%. So, ibig sabihin nun, ang prediction natin, not admitted to. This will not be admitted. When we look at the actual data, number 2 was admitted. So, mali itong prediction na to. Okay, so here you can see the correct and the wrong predictions. Ito yung actual natin, no? Actual data to. Ito yung mga prediction natin based on the GLM model. So number 3, guys, 68%. Okay, correct or wrong? Paki-chat please kung correct yung prediction or wrong prediction. Okay. Let's see. Okay, thank you, David. Thank you, Pierre. You're correct, no? Tama. Si number 3, according to our model, 68% yung probability na ma-accept siya. And indeed, guys, na-admit talaga siya, no? Si number 4, 12.9% lang yung probability na matatanggap siya. And yet, si number 4, guys, look. So this is a wrong prediction. Diba? Si number 6, 23% daw na na-admit siya. Pero dito, okay, na-admit siya. So you can see, guys, first 6 observations, may mga mali na kagad dun sa prediction natin, no? Using the binary logistic regression. Okay? So yung train data natin, di ba, tinitingnan natin, no? Kung ano yung nangyari dun sa model natin. Okay, so before I continue, guys, I just want to explain kung ano yung nangyayari sa logistic regression. Okay, so let me ano ko lang yung digital pen kasi I want us to understand what happens in a logistic regression. Saan nanggaling yung anong yan? Saan nanggaling yung mga value na 0.28, yung 0.229, 0.68, where did that come from? Okay. So, asa na siya? I-access ko lang yung yung digital pen, and let me just open. Ito na ako mag-open sa sa Excel na lang kasi ang hirap sa minsan ang hirap sa Word magsulat. Okay, let me use Excel, guys. Sorry, hindi ko pa nabuksan si Excel. And explain what's happening here. Kasi pag nakita natin yung konting math nito, maiintindihan natin kung bakit ganun yung prediction ni R. At saka, this is what happens with binary logistic regression. Okay, so bukasan tayo ng bagong worksheet. Okay, now in a binary logistic regression, the equation is, okay, di ba sa regression natin, ang equation natin is y is equal to, okay, beta null plus beta 1 times x1 plus beta 2 times x2 plus beta n times x sub n. Okay, so this is your intercept. This is our intercept. This is our first independent variable regressor. This is slope 1, slope 2, slope 3, etc. slope n. Okay. Y is our dependent variable. And sa linear regression, guys, multiple linear regression, Y should be continuous. Okay? This should be continuous. Means dapat quantitative number siya. Okay? So, usually, guys, sa multiple regression, ganun yung ginagawa natin. Ang condition dapat si Y, continuous variable. Okay? Si x1, x2, kahit ano siya, kahit factor siya, etc. For as long as Y should be continuous. Now, sa logistic regression, guys, Y is not continuous. Diba? Y is a factor. So, sa binary logistic, Y is a factor. So, factor siya. So, pag ganyan, guys, pag binary logistic regression, ganun pa rin yung equation natin. So, beta null plus beta 1, x1 plus beta 2, x2. Okay? In our case, kasi dalawa lang yung ano natin, yung regressors, yung GPA lang at saka yung rank. So, I'll just stop there. And then, guys, this is equal to, hindi siya ordinary, no? Ang tawag sa kanya, log. It's equal to the log of P over 1 minus P. Yan. Okay, unlike guys, pag multiple regression, kapag multiple linear regression, okay, it's straightforward. Ganito talaga yung equation. Pero guys, sa binary logistic, Y is equal to like this, but it's equal to this one. And we call this, guys, log. Yung log P over 1 minus P, it's called your log odds ratio. Okay? So special value, guys, yung ano natin, yung equation natin kapag binary, no? It's called log odds ratio. Bakit log? Kasi kinukuha natin log. Tapos ito, guys, odds ratio to. Okay? P is the probability of being admitted. So 1 minus P is, of course, the probability of being rejected. P over 1 minus P. Kaya ang tawag dyan, odds ratio. Okay? It's the proportion of the probability of being admitted, and 1 minus P is the probability of being rejected, di ba? Ang tawag dyan sa ratio niyan, odds ratio. Okay? What are the odds of being admitted? Okay? So iba siya dun sa probability. Magkaiba yung probability sa odds ratio. Ang odds ratio, guys, it's a proportion of the probabilities, no? Probability divided by the negative of the inverse of the probability, yung 1 minus P. Okay. So when we when we do our model, okay? So di ba ano ba yung model natin? Sulat natin dito, no? So our model is Y is equal to, ano ba yung beta null natin? Paki-dictate nga, guys, ano yung intercept, ano yung value niya? Kindly please. Ano yung value? Negative ano? Intercept, please. Guys, paki-unmute na lang, please, para mabilis tayo. Para hindi na ako magbukas-bukas, guys, ng ano. Ito kasi, kailangan natin to. Ito, guys, yung value ng regression natin, di ba? Copyin ko na nga lang. Control C. Okay, bakit ayaw?
So yung negative 4 po ba?
Yan, oo. Yan. Okay, sige. Yan. Kinapi ko na lang, guys, ha? So, given this, guys, ito yung ano natin, yung model natin. So let me write our equation. So Y is equal to, okay, let me write that. y is equal to negative 4.727, diba? Okay, so this one, plus 1.3735, 1.3735 multiplied by your GPA, diba? Okay, plus, okay, so si rank 2 wala, no? Kasi insignificant siya. So hindi papasok si rank 2 sa model natin. Ito ko na yung sulat. Plus, this one, negative 1.645 times rank 3. And then plus negative 1.5642 times rank 4. Okay. So with this, guys, with this equation, we can compute for your y. Pwede natin ma-solve si y. Okay? So gamitin natin to, this one, plus 1.3735 times whatever the GPA of the individual is. And then, okay, depende kung rank, ano siya, kung anong rank siya. Kung rank 3 siya, then this will become equal to 1. No? Kung rank 3 siya, so magkakaroon ng negative 1.645 times 1. And then this will become 0. Kasi hindi naman siya rank 4. Eh. Kung rank 4 naman siya, ito magiging 1 to, times 1 to. So this will appear now in our model. Rank 3 naman, magiging 0 to kasi times 0 na yan. Kasi hindi naman siya rank 3. Kung rank 2 siya, guys, mag-0 out, no? 0 to, 0 din to, tapos walang contribution kay rank 2. Okay? So ganun yung mangyayari, guys, no? That will happen now, that will now be our model. Okay. So let's try this, guys. Okay? Can you please, okay, so lalagay ko dito, So yung equation natin is this one, Control C, Control V. Tapos itong lalabas ng GPA, Control C, Control V. Tapos itong rank 3, isasama natin, Control C, Control V. Tapos itong rank 4, sama natin, Control C, Control V. Okay? So we're going to compute. So papakita ko lang, guys, yung equation natin. So this is our equation. Okay, so yung equation natin will be y is equal to, the odds ratio is equal to beta null plus beta 1 times GPA plus beta 2 times kulang to, rank 3 plus B3 times rank 4. Okay? Ito yung equation natin, yung actual equation natin. So therefore, ang equation talaga natin, sulat natin y is equal to, so let me copy this, Control C, Control V, okay, plus 1.3735 times your GPA, whatever your GPA is, and then minus this times rank 3, and then minus this times rank 4. Okay? So ito yung equation natin, guys, ng value ng y. Ito yung pinipredict natin. And take note, guys, y is equal to your log of your odds ratio. Log odds ratio. Okay? Yung importante yun, guys, na yung y natin is quite different from a multiple linear regression problem. Kasi pag multiple linear regression, pag nasolve natin si y, yun na yun eh. Yun na yung value ng ano natin. Yun na yung value ng dependent variable natin. Not so in your binomial logistic regression. O, sige. So gawin natin to, guys, ha? So, sige. I'll go back to train, no? Okay. Let's take a look at this. Okay, let's try to predict first observation natin. Ano yung GPA ng first observation natin? What's the GPA? Hello, guys? What's the GPA?
3.61, sir.
Yeah, 3.61. Saan natin ilalagay dito yan? Where do we put that here, guys? Di ba yung equation natin, negative 4.72 plus 1.3775 times, di ba? Times GPA. So kunin natin yung GPA ng observation 1 natin. Kung ano yung mga values na dito, ilagay natin dito sa equation. Yan. Okay? And then negative 1.1645 times ano? Times what? Ito yung rank to, guys. Yan. Rank to. Rank 3, rank 4. Anong rank ba siya, guys? Anong rank si observation 1 natin?
3, sir.
3. Therefore, ang gagawin natin dito, dito siya papasok, times 1 to. Tapos itong si rank 4, times 0. Yun. Walang contribution to. Kasi rank 4 to rank 3 siya. Ito, papasok sa equation natin. Okay, pause muna ako, guys. Any questions about that? So ano lang, nag-substitute tayo, guys, sa mga values dun sa equation natin. Okay? Alright, thank you, David. You're correct, no? Okay, so tama ba ito equation natin? Negative 4.70727 plus 1.3735 times the GPA. For number 1, the GPA is 3.61. So pinapin natin yan. Minus 1.1645. Bakit times 1? Times 1 kasi rank 3 siya. Okay? Tapos ito, bakit times 0? Times 0 kasi, guys, hindi naman siya rank 4 eh. Remember, yung model natin ito, no? Ito. Ito, rank 4, negative 1.5642. Ito yon. Para kay rank 4 lang yan. Okay? Kung rank 3 siya, ito yon. Kung rank 2, guys, walang i-contribute. Kasi hindi naman pumasok sa equation si rank 2. No? Tapos, si rank 1, magiging 0 yan. Si rank 3 pala magiging 0. Si rank 4 magiging 0. Okay? Alright. In that case, guys, rank 1 and rank 2 will be the same. Kung ano yung prediction natin kay rank 2, ganun din magiging prediction natin kay rank 1. You know why, guys? Kasi si rank 1, guys, all of this will be 0. Lahat yan is 0 out. And since hindi naman din papasok tong rank 2 na to, then to compute for rank 1, ang kukunin na natin si intercept at saka si GPA. Okay? To compute for rank 2, ang kukunin din natin yung dalawa lang. Hindi papasok tong tatlong to. Okay, I hope that's clear. All right, so sige. Control Enter. Okay, negative 9,33165. Okay. So, ito, no? Control C. Balik tayo kay Excel, ha? Control V. Ay, ano siya, nag-blue. Okay. Okay, no? Ito yung value nun. Ito si Y, guys. Si Y. Pero, sige, tingnan muna natin, guys, ha? Okay, let me just explain. Okay, and just tell you, okay, Y. Y is equal to yung negative 9, ano, negative 933, ano, guys? Hello? Pakidictate, please. Hello? Wala bang sasagot? Ito, yung kanina. Negative 93317, 165. Okay, yan si ano, negative 1933 165 ba? Okay. Etc. Ano pa yan, no? Okay. Now, what's y equal to, guys? Remember, ano yung y natin? Anong tawag natin kay y, guys? Huh?
Dependent variable, sir.
Yeah, dependent variable, pero may value si y. Diba? Y is equal to yung log odds natin. Diba? Log ng P over 1 minus P. Okay? So pag kinompute natin yung value, guys, ng y, okay, we're not getting the probabilities. Okay? So, ito gusto natin eh. Ano ba yung probability na ma-accept si sample number 1? Eh, ang binigay sa atin ito, y is equal to negative 933,165. That's not the probability. No? Hindi probability yan. Log odds yan. Log odds ratio. So, we have to do a little algebra in order to compute for your P. Okay, so punta tayo dito ha. So, from y is equal to log P. Okay. P over 1 minus P. Okay, we'll do some manipulation. Okay, I don't know if you learned this in your other algebra, pero paano natin paano natin matatanggal tong log? How to get the log, how to remove the log is to do the inverse of log. The inverse of log is the exponential, e. So ang gagawin natin, erase natin to sa e to the y is equal to e to the log p over 1 minus p. Okay, by doing so guys, e to the log will cancel out. So e to the y will now be p over 1 minus p. Okay? So yan na yung equation natin, ano? Now we need just to solve for p. Ang gusto natin malaman yung probability. Okay, yun ang sinosolve natin eh. Ano ba yung probability na ma-admit siya o hindi? Kaso the problem is, sa equation natin, log odds yung y na binibigay. So you have to convert, no? Okay, so continuing guys. So ulit ako. So let's simplify that. Magiging e to the y, di ba? Times 1 minus p is equal to p. Okay, so just cross multiply. And then, kailangan natin guys, andito na yung P, may P pa tayo dito, ilipat natin si P na to dito sa side na to. So let's distribute e to the y, okay, minus e to the y times P, diba? Dinistribute lang natin, okay, is equal to P. Alright, then let's join e to the y is equal to, ano na, P. Then this one plus P times e to the y. Right? Transpose lang natin. Basic algebra lang, no? Basic algebra lang to. And then, so e to the y is equal to, let's factor P, P, okay, times 1 plus e to the y. Okay? Therefore, guys, masosolve na natin si P. Okay, P will now be equal to ano? E to the y over 1 plus e to the y. Yun. Okay. So since we know y guys, we know y eh. Diba? Alam natin yung value ng y, then we can compute for P. Okay. So for sample number 1, what's the probability? What's the log odds ratio? Ano yung log odds ratio niya? Ito, di ba? Okay. It's this one. So, in order to compute for the probability, it will be equal to, yung e guys sa r, exp. No? But e to the y, so it's this one, Control C. Gamitin natin si, si e, si y, divided by, ano yung ano natin? 1 plus e to the y. Yan. Okay? E to the y over 1 plus e to the y. Of course, dapat nakaparenthesis siya. No? Hindi na kailangan itong isa. Okay? Hindi na kailangan kasi isa lang. Ay, wait. Kailangan pala. Kailangan to close out this denominator. Sige nga guys, paki-compute tapos paki-sabi sa akin kung ano yung value nito. Kindly compute please and please tell me what the value of this is. Paki-chat please. So dapat na-compute nyo muna si y. Tapos i-convert nyo sa y into a p. Kasi ang formula ng P is equal to e to the y over 1 plus e to the y. Value guys, value ng P. Hello? Hello, please. Pakigawa. Kung ano yung value ng, ang value na makukuha natin dito guys, yung P, P. Because it's this one. The probability is equal to e to the y over 1 plus e to the y. Yun ang probability natin. So tingnan ko kung ano nakuha nyo. 0.2822. Yan. Okay, sige. Good. So let's run this. Ira-run ko siya. Enter. There. 0.282283. Ngayon, how does that compare with our forecast, with the model's forecast? Ano sabi dito? Ayan guys, oh. So si number 1.2822, nagkaiba na lang dun sa fifth and the sixth decimal place kasi because of rounding off, no? But the first four decimal place, tama, oh. 2822. Okay, so that is how the model gets the probability. Okay, diyan kinukuha, no? Yan kung paano kukunin yung yung probability. O sige nga guys, kunin natin, tingnan ulit natin Let's do dito sa first natin. Okay. Tingnan natin si number 4. Ano ba to? 1 2 3 4. 1 2 3 4. Ayan, number 4 siya guys, number 4. Okay, number 4. So let's just copy this quickly. Pwede natin i-copyhin na lang to, no? Itong equation na to. Control C, Control V. Tapos papalitan natin si number 4, ang GPA niya is 3.19, no? Ito. 3.19, Control C. Papalitan natin to. Ito yung GPA na to, no? Control V. So naging 3.19 yung GPA, tapos ano pa? Fourth siya, no? Fourth siya. So ibig sabihin ito times 0 to. Tapos ito times 1. Fourth rank kasi siya, no? Diba guys? Okay, what will be our Y value? Paki-chat nga please. Remember, ang ibibigay sa atin ito yung Y value. Hindi pa yan yung probability. Our Y value is negative 9.09. Okay, that's correct, no? Tama. Thank you, David. Okay, yan. Negative 9.09735. But that's the log odds ratio, no? Ano ngayon yung probability niyan? Copyhin natin to. Yung equation na to, yung e to the y, Control C, Control V, palitan na lang natin tong y value, Control C. Let's replace this. Control V, and then let's replace this. Control V, there. And then you get 0.129, okay? And let's compare it with our model. 0.1290 tayo. Okay, 1290, diba? Okay, the same to the fifth decimal place. Okay, so clear yun guys, clear on how the model is predicting the probability of being admitted or not. Ginagamit ng model na to, yung binary logistic regression, yung odds ratio. Okay, yung log odds ratio. So that's how this is computed. Okay, questions guys? Questions ba so far? Okay, so ito guys, in-explain ko lang, in-explain ko lang. So let's leave that kasi na-explain ko na naman. Okay. So tingnan na natin ngayon guys, no? So what we're going to do is we're going to create this object pred1. Okay, pred1. Ang gagawin natin, if else, no? If P1 is greater than 0.5, okay, kasi di ba yung P1 natin probabilities to eh. Tingnan natin, view natin, view si P1. Ano ba laman ni P1? Yan, no? Di ba mga probabilities? Yan. These are probabilities. So, convert natin siya, guys, into 1 or 0. Okay? Ano yung 1? Admit. No? If the probability is greater than 0.5, then admit yon. Otherwise, 0 siya. Not admit siya. No? Okay, so ito yung code natin doon. Let's create this object, pred1. And pred1 is, gamitin natin, if else, if P1 is greater than 0.5, give it a 1. Otherwise, give it a 0. Okay? So, lagyan natin ng pred1 para makita natin. No? So, let's run these two. Dali lang guys, ha? Okay. All right. So, ito din pred1 natin. I-view na lang natin guys para mas maganda. View pred1. Okay, ito yung pred1 guys, no? 0, 0, 1, 0, 0, 0. Bakit naging 0, 0, 1, 0 to? Kasi if we take a look at P1, diba? Ito, 0.28. So, 0 to. Ito, 0.29 o 0.3, 0 din to. Ito, 0.68 to. So, 1 yan. Accepted yan. Okay? So, what we did with pred1 was to convert itong, ano natin, itong vector ng probabilities into vector ng 0 or 1s. Binary siya. Okay? And then, because we have converted it, we now have an object called pred1. Okay, we can now compare it with sa train natin, ito, si admit. Di ba kasi si admit 0 or 1 din, di ba? So, isa side by side natin siya. Tingnan natin kung tama ba, i-compare natin yung predicted value natin with our actual value. Okay? So, ito na yun. Tab 1, table natin, predicted is equal to pred1, actual is equal to train, yung admit lang. Okay, so let's run this. This is our confusion matrix. Control Enter. Okay, there. Okay. So if we take a look at this, predict nyo na 0, actual niya 0, tama, 208. Predict nyo na 1, actual niya 129, tama. Predict nyo na 1, pero actual niya 0, okay, 15 ng mali. Dito, predict niya na 0, pero actually natanggap yon, so 73 mali. Okay? So just like what we did in the previous exercises, we can now compute for the percentage correct and incorrect information. Run natin to. Okay. So 73% ang correctly specified, 27% ang wrongly specified. So that's how our model was able to predict our data. And then syempre ang ginagawa natin, di ba? Gagamitin natin to kay test data to. We have to use this for test data. So first we predict natin using the my model, okay, using the test data, and type is equal to response. Okay? And then after that, yung i-convert din natin sa sa 0 or 1, and then i-compute natin, no? Okay, so we can run everything here sabay-sabay na. Okay, let's take a look at this. Okay, lagyan natin ng correct, Control C, ng correct predictions para kita kagad. Okay, here, Control V. Dinagdag ko lang yung correct predictions, no? Okay, let's run this again. Okay, so here is our confusion matrix. Actual yung 0, predict siya na 0. So 48 correct. No? 48 and 5 correct. 20 and 2 are wrongly specified. So 72.9%, 29%. So okay, kasi guys, halos, wait, tama ba? Test 72.92, 72.92, 308. Bakit pareho siya? Okay, may mali ba ako dito? Test data. Right, let me check guys. Let's check the view P2. Okay, 75 entries. Okay. Tama, 75 entries. Tapos, predict natin. Okay, tama to. Spread 2. Test data. Tama. Okay. Diagonal. Ay, mali ito guys. Sorry. This should be tab 2. Table 2 to. No? Table 2. Sorry, this kaya pala pareho. Sabi ko, guys, kasi usually impossible na magkapareho yung yung percentage ng correct prediction ng training at saka testing. Parehong-pareho kanina, oh. It's 100% na parehong-pareho sila, so may mali. Sabi ko may mali dito. Yan, so pinalitan ko guys ang tab 2 for predict 2. So sige, i-run ko na to. Okay. There. Okay, magkaiba na. Imposible guys na parehong-pareho yung percentage ng correct at saka wrong, no? So here, guys, tama yung 48 at saka yung 5, mali yung 2 at saka yung 20. So you have here 70% yung 71%, around 71% correctly specified, 29% wrongly specified. Okay. So yun guys ang logistic regression, no? And then we're going to compare this, kasi nasa machine learning tayo, we're going to compare this with another method which is also a very powerful method, yung FFT, yung fast and frugal trees, okay, which we're going to discuss now. Itong huli guys, kinuha lang natin yung goodness of fit test ng model natin, itong may model natin, to see if this is statistically significant. Okay, so lumalabas dito guys, yung natin, chi-square, it's less than 0.05. So ang null hypothesis natin dito is that the model is not okay, no? Hindi okay yung model natin. Hindi okay yung logistic regression model natin to predict admit. Okay, that's our null hypothesis. And what's our conclusion? We reject the null hypothesis that our binary logistic regression model is not capable of predicting admit. Okay, we have strong reason to believe that okay yung model natin na statistically significant siya. Okay, so ito lang yung ibig sabihin ng code na to. Okay, so with that guys, I hope that increases your understanding of logistic regression model. So simple lang actually siya, no? Just make sure that your decision, that your dependent variable is a categorical variable. Okay, kasi this is used for classification. Okay, question. Pwede ba natin gawin yung yung data natin last time, yung NSPF sa binary logistic regression? Naalala niyo guys, yung 22, 23 variables natin, where we determined whether the fetus of the mother was yung normal, yung heart niya, or suspect or pathologic. That was our first discussion on decision tree. Pwede bang gamitin dito yon sa binary logistic regression? Answer? Pwede. Okay. Ang answer guys, hindi. Bakit? Bakit hindi? Kasi guys, yung sa NSPF natin, normal, suspect, and pathologic, tatlo yun. No? Di ba? Tatlo siya. Tatlo yung factors natin doon. Eh, pag binary, dalawa lang. Okay? So if we're going to use logistic regression, anong klaseng logistic regression ang dapat gagamitin natin dun sa cardio data natin? Anyone? Sinabi ko na kanina to, guys. Anong gagamitin natin? Okay, it's called your multinomial. Okay, multinomial siya. Multinomial. Okay, multinomial logistic regression. Ang ginawa natin ngayon, binomial logistic regression. Halos pareho lang naman siya, guys. Nag-iiba lang, guys, kasi nagkakaiba lang sa sa interpretation, no? Sa konti sa method. Pero log odds ratio din yan. Okay. All right. So we leave this, yung logistic binomial regression natin. Kindly open the last file that we're going to do today, yung frugal trees. Now, this is interesting. Kasi I want you, after this, to work on this binary data and do this FFT, this frugal, fast and frugal tree, and then compare it with your logistic regression. Now, the reason why I'm going to use another data now is because I want you to compare itong binary logistic regression natin versus the model that we're going to learn now, si FFT. No? So, sana mag-run yung model na to, yung package na to, kasi minsan nagkakaproblema dun sa package. Eh. Okay, kindly open that, guys, yung FFT file natin. Okay, so close ko na muna itong mga close muna ako kasi kasi ang dami ng dami ng open na Okay. All right. So let's open, guys. Ito ba yung binigay ko sa inyo? What did I share with you, class? Okay, let me see. FFT heart. Heart pala. Heart. So hindi ko yata na-open yun. Ito. FFT heart. Okay. All right. So we'll end in this, guys. Okay. Fast and frugal trees. FFT. FFT. Fast and frugal trees. Okay. So type din siya ng decision tree. Okay. So let's take a look at three scenarios. No? So may physician, may doctor. So pasok yung patient, no? May chest pain siya. And then you need to decide quickly kung ano ba to, yung ang problema ba nito sa heart niya or just lang siya, yung regular lang na na problem. Hindi siya, not something about the heart. Hindi siya kailangan din sa coronary care unit, just a regular hospital bed, no? Okay, so pag ganyan, guys, yung mga ganitong klaseng situation, kailangan mabilis yung mabilis yung yung decision ng doctor. So is there a method, is there a methodology that the doctor can use so that mabilis yung yung decision niya? Okay, how about this one? May isang soldier, no? So near a military checkpoint. So dapat malaman kung yung bang yan, yung approaching vehicle ba yan, hostile or friendly, no? Okay, so is there a methodology by which the guard, no? Or the soldier can decide kung hostile ba yan o friendly? Okay, si stock portfolio advisor. Okay, may ba siya, may model ba siya na malalaman, magagamit para ma-decide niya na aalis siya dun sa i-unload niya yung shares niya sa isang investment o hindi? Okay, these are examples of what we call binary classifications. Yes or no, okay? Ano ba to? Yung sa coronary ba to or just a regular hospital bed? Okay, friendly ano ba to or hostile force? Okay? To pull out or not to pull out? Yung parang kanina, admit or not to admit? Okay, so this model, guys, you can you can apply for yung data natin kanina, yung admit, no? But we're not doing that now kasi gusto ko kayo mismo yung mag-compare. No? Okay, and this one also, you can use this to in binary logistic regression and try to see kung sino mas maganda na method. Okay, so this is one method by which we can use yung FFT, yung fast and frugal decision. And this was developed in 2008 pa ni Martin yun, etc. No? 2008. Kaso dati guys, actually yung 2003 pala. Nung 2003, when this was developed, ano lang, yung paper and pen lang. So paper and pen lang siya. So medyo involved yung computation. Simple lang pero involved. No? But unlike now, meron ng package R where we can do FFT, yung fast and frugal. Okay? So, bakit fast and frugal? May mga advantages ang FFT. As the name suggests, guys, fast na, frugal pa. Ibig sabihin, wala masyadong inputs na kailangan. Okay, sabi nga natin dito, unlike regression, katulad ng logistic regression natin, si fast and future trees allow people to make fast, accurate decisions. Limited information, kaya na niya. No? Without requiring statistical training or calculation device. Okay, so si FFT guys, it's a good methodology also. Okay, kaso ang question, bakit kaya hindi siya masyadong ginagamit? Okay, so FFTs have been successfully used to both describe decision process and to provide prescriptive guides for effective real-world decision making in a variety of domains. So ginagamit siya sa medical, legal, financial, managerial decision making. Yes, ginagamit tong FFT. But despite that, sabi ko nga guys dito na may mga reasons kung bakit hindi siya masyadong ginagamit. Okay, kasi number one, marami ng tools ngayon, decision tools, na gumagamit ng sophisticated na softwares, katulad ng regression. May free R naman, di ba? Okay, so also, since napakasimple niya, parang ang suspicion ng mga tao, napakasimple naman yan, parang hindi yata, accurate or outdated na siya. No? And there are, later on guys, we'll discuss yung RF, yung random forest, and SVMs, yung support vector machines. Okay, as part of our machine learning studies. No? Okay, so, however, guys, be that as it may, sabi natin, FFTs, guys, make it really fast, make it really easy to do a model. So, tapos dinevelop pa nila Philips, no? Yung FFTrees in R that make it easy to create, visualize, and evaluate FFTs. Okay, so ngayon, kaya na nila makipag-compete dun sa mga ibang machine learning tools. Okay, so we're now going to use FFT. Okay, so we're going to use the HART package, HART data that comes with the FFT package. So pakitanggal nga ito guys, pakitanggal yung asterisk dito, paki-install kindly install si FFTrees. And then tell me guys, kasi minsan nagkaka-problema sa pag-install nito eh. I've encountered several times having problems installing this package. Could you please try if you're able to install FFTrees? And then paki-chat please kung na-install nyo. Okay, let me see. Yun. Okay, so yung iba not available in this version. Okay, so let's try to see guys kung dito ako minsan nagkaka-problema. Okay, this is another way to install it. So first, install natin yung remotes package and then yung require the library ng remotes. And then ito yung second part, install din natin si recipes. And then from GitHub, kukunin natin yung FFTrees ni Phillips, ni Nathaniel Phillips. And then saka natin i-library. Okay, so siguro i-install nyo muna tong 1 and 2 remotes muna. Pwedeng sabay na yan. Tapos dito guys, siguro one at a time. No? Yung recipes muna. Tapos itong GitHub. Tapos saka yung library ng FFTrees. Could you kindly do that guys please? Hopefully mag-okay sa inyo. Siguro may bug pa tong package na to kasi relatively medyo bago pa rin tong package na to. Okay, let me see. Ayan, good, Pierre. Okay, good. That's great. Let's wait for the others. Sana mag-run din. Kamusta na, David, tsaka Hased? Okay na ba yung naload yung FFT? Kung okay na po, pero yung recipe na package. Okay, sige. Okay, pero dapat ituloy mo hindi lang yung recipe, no? Okay. Could you kindly check here kung i-type mo dito sa packages? Type FFTrees. Check nyo guys kung nag-appear na si FFTrees sa packages. Wala. Okay, dito sa sa packages and then FFTrees. Check nyo ulit guys, library FFTrees. Okay. So sa akin nag-load, no? Okay, wala. Anyway, tingnan natin ha. Let's check guys kung mag-work nga yung FFTrees. How about if you access yung library FFTrees, what happens? I-run nyo nga itong library FFTrees. Okay. John and David, so ibig sabihin ano pa siya? Hindi mo pa ma-access yung yung script window, script pane. No package. Okay, sige. Tingnan natin guys, try natin, no? Okay. So siguro may bug pa tong itong FFTrees pero it's a very powerful package. Okay, so simple lang siya, no? So ito nga yung guide Yung guide hindi mabuksan. I've been trying to open this, vignette not found, vignette guide not found. There should be this this guide pero wala no? So I think may may bug pa tong na to. Okay, now yung package na to guys comes with a data, no? Heart.train and heart.test. Sila na mismo nag-split yung package na to, no? Heart.train, so we don't need to split this. Okay, so let's run this guys. Okay, tingnan niyo ako magra-run kung ma-access niyo yung yung heart.test at saka heart.train. Okay, were you able to access it? Na-access nyo ba guys? Yung heart.train and heart.test. Not found. Okay, sige. Okay, anyway guys, mamaya after this siguro i-turn close yung muna yung R tapos subukan nyo ulit, no? Try yung pag-install ng FFTrees. And siguro guys, I suggest that you try to see kasi pag may mga ganyang issue, may mga may mga sir din pala sa akin tumutuloy. Comes to library pala. Okay, kay Pure din wala, no? Okay, so try to also search guys sa net. Kung lagay nyo, FFTrees FFTrees package does not upload, no? So and then may mga suggestions sila kung paano gagawin yon. So ako din guys na experience ko rin yon. In fact, ito asan na tayo? Close ko muna si Iris, testing, training. So where's okay. All right. So in the meantime, guys, observe na, tingnan nyo na lang muna, no? Okay. So para konting lang naman to yung codes niya, hindi masyadong marami. At saka yung codes niya hindi gaanong kahirap, no? So we have here two data sets. Yung una, yung train, okay, 150 observations, 16 variables. Tapos si test, 153 mas marami pa nga si test. Ang ginawa nila, mas marami yung test size kaysa kay train. Okay? So we have here some medical data, yung age, yung gender, yung sex, 0 is female, 1 is male. Tapos yung, ano ba yung CP? Nakalimutan ko yung CP. Tapos, BP, yung blood pressure when at rest, cholesterol level, fast blood, sorry guys, I forgot pero resting ECG, and then ano to, it's a chemical, no? Okay, so what we want to do is parang yung kanina logistic regression, we would like to determine if based on this data kung may heart disease ba to, no? Or normal lang siya. Yun ang gusto natin malaman. Kung okay lang ba to or suspect for heart disease or stroke, kung masa-stroke na. So yung mga false dito, ibig sabihin, wala silang heart disease, no? Okay, itong true, yung may heart disease. Okay, so we're going to make use of itong FFT, yung fast and frugal trees, in order to, okay, so na yun, hindi ito. In order to predict kung kung meron bang heart disease or wala. And then that variable, guys, yung dependent variable natin is diagnosis. Ito, diagnosis. Okay, so diagnosis, this will be our criterion. And then our data will be heart.train. Tapos, so medyo iba yung ano to yung syntax, ano? Ang testing data natin, ilalagay na natin dito, data.test is equal to heart.test. Then we'll give it a name, yung output natin, ER decisions, emergency room decisions. And then our decision labels will be stable, kung stable yung tao, or may heart attack siya. Okay, so if I run this, guys, okay, so meron na tayo ditong, okay, so, and then we plot, so we inspect the object, heart.fft, kasi ito yan, no? So we created an object, it's a tree, no? FF tree, it's a fast and frugal tree. So medyo ibang klaseng tree to. If I run this, guys, enter, ayan. So if you take a look at this, so sabi daw 7 FFT, no? 7 fast and frugal tree in order to predict yung diagnosis natin. Okay? And then ito yung ano niya, ito yung decision rule. If the thal, I forgot this chemical, if yung chemical daw nito is equal to either RD or FD, okay, then heart attack yan. So, tingnan natin guys yung data. No? Ito yung I'm sorry guys, I forgot the name of the chemical. Pero either normal, RD, or FD to. No? Yan. Normal, RD, FD. Yun yung thal natin. So, ang sabi dito, lapit ko natin dito. So our model tells us that if the thal, whatever that chemical is equal to either RD or FD, then heart attack agad yun. Condition na heart attack. Kung hindi guys, punta kayo kay CP. Punta tayo kay CP. So ito si CP, no? CP. Okay, there are different types of CP then. So sabi niya, if CP is not equal to A, then stable yan. Okay, so it's stable. So if we take a look at our train data, ito, so first, di ba, ito, thal. Normal, so wala na, no? Since normal yung thal, wala na yan, normal na yan, okay? Normal na siya. Kasi dito, magde-decide lang sa thal daw, kung RD o FD yan, may heart attack na yan. Okay? Normal, si thal, ibig sabihin, ang next step, pupunta tayo kay CP. Tapos ano sabi? If CP is not equal to A, then dapat stable na siya. Okay, so dito, punta tayo dito. CP naman daw, not equal to A. So ito NP to, no? So it's not equal to A, then this person is stable. So based on our model, stable siya. So false. Tama ito. Ibig sabihin, walang heart attack. No? Yung false is no heart attack. Yung true is may heart attack. Okay? 3 guys. Okay. Then, may ano tayo dito, may pangatlo. No? If, kunyari, if CP is not equal to A, no? Then stable siya. And then, if CA, so paano kung ano pala? Kung if CP is equal to A, titingnan naman natin si CA. Okay, if CA is less than or equal to 0, then stable siya. Otherwise, may heart attack. Okay, clear? So yun yung ano natin, yun ang decision rule natin, no? So let's take a look at this. Kasi pag normal dito, pupunta muna tayo sa CP, no? Okay, ano ba normal dito? Normal daw, tingnan natin to guys, si number 9. If it's normal, hindi. Kung yung tal guys, normal, what are we going to do? What are we going to do? Punta agad sa CP, no? If it's not equal to A, then stable yan. Otherwise, kung A siya, pupunta kay CA. If CA is less than or equal to 0, then stable siya. Asan si CA? Okay. Ito, no? All right. So let's continue, guys. Okay, then that was the first. Ito naman, you can use the inwards of the model. So ito, no? If thal is equal to RDFD, decide heart attack. If CP is not equal to A, halos pareho lang naman, decide stable. If CA is less than or equal to 0, decide stable. Otherwise, decide heart attack. So inwards lang, no? Inwards lang to. And then let's go to summary. Ano yung summary? Control Enter. Okay, ito guys, ito. Nagkakaproblema ako dito kasi actually dapat hindi ganito yung ano eh. Hindi ganito yung result eh. Dapat may values dito sa test. Okay, so I'm having a problem also with my FFTrees, no? But I decided to just push through with it kasi pwede namang hindi natin titinan yung summary kasi ito incomplete, no? Walang lumalabas na test. Kasi remember, may binigay tayong test data. Okay? So summary heart FFT, kasi yun yung model natin, yun, heart FFT. Then when we ask R to summarize it, ang lumalabas lang train, tapos yung test wala, tapos mali pa, no? Kasi tiyan nyo, mali-mali yung, it's just the same, hindi pa pwede yun. So I am getting an error dito sa summary function ng FFT. Pero be that as it may, guys, pwede naman natin gamitin to, no? Yung plot. Okay, ano naman tong plot, guys? So let's use plot heart.fft and then stats is equal to false. Ibig sabihin, wag niya ilagay yung stats. So ito lang 'yon, no? Very basic lang siya. Ito yung decision tree natin. So ito yung name, ER decisions. If the thal nakalimutan ko yung pangalan talaga, sorry. If the thal is equal to RD or FD, then decide heart attack na yun. If it's not RD or FD, punta kay CP. If CP is not equal to A, then stable yan. However, if CP is equal, then if CP is equal to A, punta tayo kay CA. Okay? If CA is 0 or less than 0, then stable yan. And then if CA is greater than 0, heart attack yan. Okay? 1, 2, 3, 4, 5, 6 branches. 6 yung branches natin dito. Okay? So, ito yung ano natin. Ito yung fast and frugal tree decision. Diba? Ang bilis, guys. Ang bilis. And then, minimum of ano, ang tininan lang niya, thal, CP, at saka CA. Despite the fact, guys, na ilan yung ano natin? 15. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 predictors. Pero ang tinignan lang niya guys, yung SAL, yung CP, at saka yung CA. Okay, kaya ang tawag sa kanya frugal, no? Using as few inputs as possible. So we can now plot yung whole FFT natin. Ayan. So guys, maganda, no? Okay? Wala na akong ibang nakitang guys, machine learning tool na which gives us this kind of an output. Ang ganda ng output ng FFT actually, no? Okay, so what does this indicate? First guys, dun sa data natin, okay, dun sa data natin guys, there are 150 observations, no? 150 observations. Ang nasa data natin, ang stable doon 84, ang actual na heart attack 66. Okay, so it means 56% yung stable, 44% yung na heart attack, yung data natin. Okay. Then let's go here, FFT number 1 of 7. 1, 2, 3, 4, 5, 6, 7. So it starts with this one. Binibilang niya to, no? Okay, first. Okay, if the thal daw is equal to RDFD, diba? Sabi natin, heart attack yan, H. Punta dito. No? So dito, based on the model, yung heart attack, ang tama na na-predict is 47. Okay? 16, yung predict natin na may heart attack, pero wala naman pala siyang heart attack. Okay, remember ito guys, kino-compare yung actual value at saka yung model natin. Okay, then after this, sabi natin, after this, if the thal is not equal to RD and FT, go first to CP. Okay, is CP not equal to A? Pag not equal to A yan, punta tayo, stable na yan. Okay, so dito, sa portion na to, ang tamang na-predict, 55, ang maling na-predict, 8. So every step, pinapakita niya, no? Okay, and then here, pag si CP not equal to A, punta tayo kay CA. Okay, is CA less than or equal to 0? Stable yan. And dito sa branch na to, 11 yung correctly interpreted, predicted, 4 yung wrong. Okay? Otherwise, go to, siyempre, CA greater than 0, heart attack yan. And then, dalawa daw yung wrongly predicted, 7 yung correctly predicted. So that, guys, is the diagram for the FFT. So this is now ito ngayon guys, yung natin, yung confusion matrix. No? Okay? Ito yung prediction. Okay? Ito yung actual. Okay. Decision, predict natin may heart attack 54, actually may heart attack siya. So tama. Predict natin na magkaka-heart attack pero turns out to be stable siya, 18 yung mali. So tama dito yung 54 plus 66, mali yung 12 at saka 18. Okay? Alright, so itong mga metrics to, no, yung mean Q used, percentage Q information, sensitivity, specificity. Okay, I leave you guys to research on what these values are. Itong mean Q use, ibig sabihin, on the average, ang ginagamit lang ng model natin na information is 1.7 ano ba? What's the term for that? Parameters. Okay, yung mga Qs 1.7 lang. Okay, and then percentage I forgot yung pangalan ng PCI. Okay, sensitivity 82%, specificity 79%. So this may mga ibig sabihin to, no? And then ito, guys, this is also interesting. Ano ba yung ROI, ROC, operating something to? I forgot the name of ROC. Hindi na kasi masyadong ginagamit tong term na to na ROC. But if you take a look at this, guys, so you need to understand what sensitivity is and then what specificity is, okay, in order to understand this. So these are different models, no? FFT, classification and regression technique, no? It's yung CART. logistic regression, random forest, and vector machine to. S is support vector machine. Okay? So kinompare niya kung sino mas maganda, no? So it turns out that si one, guys, quite high in specificity. Ito yung si one yung sa atin, no? Yung green, no? Okay? High in sensitivity, but quite low in specificity. Okay? So halos kamatch natin si LR in terms of sensitivity, but we defeat si logistic regression in terms of specificity. Okay? Talo lang tayo ni si number 4, anong kulay ito? Ito? Okay, then what's that? Okay, cart, tapos ito yung logistic, ito yung SVM. I can't see SVM here. Okay, but we can see here that we can see here na ito yung green natin, yung fast and frugal, guys. We can see that our model outperforms, no? Si LR, si cart, no? Si random forest, asan na si random forest? Hindi ko makita. Ito ba si random forest? Okay, I'm not sure if this is random forest, pero si random forest, okay siya sa sensitivity, pero ang baba niya sa specificity. Okay, so this is just a comparison. Which means, guys, itong FFT na to, itong FFT package na to, it does also generate yung CART, yung LR, yung RF, tapos kino-compare niya with FFT. Okay? So, it's a very beautiful diagram. No? Gusto ko yung diagram itong FFT. Okay, so pwede rin natin, guys, gamitin yung Qs. Okay, but ito, guys, Qs. Okay, it's also a plot. Okay, medyo naghahang. Okay, medyo naghang, no? Okay, so tuloy na lang ako, guys, no? Now, when we apply it now to a test data, di ba? Kasi ang ginamit natin yung yung train data. What happens when we use this for test data? Come on, please. Okay, naglolo ko na naman tong. Okay. Ito kanina yung quiz pala, no? Okay, so this is very interesting, guys, yung sensitivity to at saka yung specificity. Okay, so pakitingnan nyo, guys, kung ano ibig sabihin sensitivity, because it has something to do with the accuracy in predicting the values. So suspend ko na muna yung discussion nito. Medyo natagalan pala yung sa pag-run nito. So I'll just run this. Okay, ito naman, guys, yung result for the test data. Kasi kanina train data yan, di ba? So ito yung test data, guys, no? Okay, notice that okay, so 153 siya, no? 153 observations kasi kanina kanina 150 observations. So ito, saldi ng simula, ganun din, ano? Ganun din, CP din, CA, tapos ito may additional, no? May additional dito. Kanina kasi natapos yung natapos kay CA yung kay train data natin. Pero dito nagdagdag pa, no? Nagdagdag pa ng slope, tapos, okay, nagdagdag ng slope, and then, so medyo iba yung model dun sa test data. Okay, and then you have again here your confusion matrix, and then your accuracy testing, and then the ROC. So dito, guys, 2. For our test data, mataas siya dito sa sensitivity. Okay, sa specificity, guys, tinalo niya si random forest, okay? And then, kasi ito, guys, yung sensitivity as tsaka specificity, the higher, the better. So, kahit na simple-simple lang si FFT, guys, it can compare with the more sophisticated na models like yung logistic regression. Okay, in fact, dito talo na naman yung si logistic, itong blue na to. Talo niya in terms of sensitivity, talo din niya in terms of specificity. Okay? So, that tells us something about yung FFT, no? Yung FFTrees. Okay, and then here, for this two, naran ko na ba to? Okay, naran ko na pala, sorry. Okay, then guys, ito I have to, okay. Meron ding data dun sa FFT yung ano yung heart disease, kay new data. So if I run this, tapos predict natin, tapos okay, ito na yung last, no? We can also create, dito medyo nagka-problema ako guys ano no sa, so I will not anymore discuss this, pero you can modify the model. So dito naglagay tayo ng my.3, tapos pwede natin dagdagan, no? Pwede natin dagdagan, kunyari ayaw natin na yung TAL lang at saka CP at saka CA. So pwede natin ipasok si sex, no? Ipasok si age. Okay, tapos magdagdag pa tayo ng TAL dito. Okay? So this can be done. Kaso nga lang medyo nagkakaproblema ako dito kaya I will have to still review this. Okay? So in a nutshell guys, ganun yung ano si FFT. So very simple siya pero very rich in information yung binibigay. So I want you to, as an exercise, I want you to perform FFT with the iris yung data set natin kanina, no? Kasi si hindi, wait. Yung admit pala, yung admit. Kasi kanina yung ano natin, yung logistic regression, admit or not admit. So binary 'yon. Si FFT kasi binary din siya, no? So dito, heart attack ba or okay lang. So when you have a binary decision variable or dependent variable, then you can make use of FFT. So it will be good to compare si logistic at saka si FFT. So as an exercise, I want you to use the admit dataset and run it in FFT and see, kasi kanina 73% yata yung ano yung correct prediction natin kay logistic, no? Tingnan natin kung dito kung magiging mataas ba tong prediction rate niya dito. Okay? All right. So guys, thank you so much. That ends our discussion for today. I hope you learned something. So next week, guys, I'll meet you on Saturday, di ba? So another 3 hours to compensate for the sessions that we're going to miss this coming week. Okay? So any questions, guys? Stop recording.